The next part is a bunch of formulas in topic 5 which you need to know. The first one is acceleration is equal to change in velocity over time. Delta V, by the way, stands for V minus U. So that's what this stands for. V is final velocity, U is initial velocity. And remember, velocity is always in meters per second. So meters per second. T stands for time, which is in seconds, and A stands for acceleration, which is in meters per second squared. Again, they should give this to you in the exam. Otherwise, if they don't, it's best to memorize it, because you don't want it to be the first time you've seen it in an exam. Now, by the way, going back to V minus U, how can you remember that U is initial velocity? A good way to remember that is U comes first in the alphabet and then V. So U is initial and V is final. That's how you can remember that. Again, another formula, V squared minus U squared is equal to 2A. Again, we know 2 is just a number, A is acceleration. S actually stands for distance, and it's measured in meters. This equation, we're going to talk about that, and momentum, of course, that's coming up as well. So this equation over here, by the way, is only in triple, so combined science don't have to know that. Moving on, a few values that you should know off by heart. So a person walking, a person running, these values, they might expect you to just, because they might give you a question, and you might be expected to just use the values over here to answer it. Now over here we have a distance time graph. So there are two types of graphs you have to know about. One is distance time graph, then you have a velocity to time graph. So starting with the distance time graph, we can see that you've got, on the x-axis you have time, on the y-axis you have distance. So we have the gradient of this line is going to be speed. So if you have a steady gradient, that's steady speed. If there's no gradient, if it's flat, that means the object or whatever it is not moving. If it's curving upwards, it's accelerating, and if it's curving downwards, it's not downwards already. It's curving. If it's curving back to a flat point, that means it's decelerating. And if it was to continue on from here on, if it was to continue flat, that means it has stopped. Okay, and a velocity time graph, looks very similar, but remember the different parts of the graph mean different things. So here, a steady line means constant acceleration, whereas before in distance time it meant steady speed. So make sure you draw both of these graphs out a couple of times with all the different types of lines, and make sure you know what those mean. Also, going back to this one more time, imagine if it said to you that so let's say from somewhere over here that the line goes back to 0. What does that mean? That's also a steady speed, but because it's going back to 0, that means it's going back to the origin, so from where it started. Now, in velocity to time graph, they could ask you to work out the distance. So for example, they'll say, let's say from 0 to let's say 10 seconds, work out how much distance the object has traveled. So the best way to do that is to find the area under the curve. So you're going to make a little line here. Now you've got a certain shape. You can actually convert this into a triangle and a square. So here you got a triangle, and here you have it's not a square, it's actually a rectangle. So you've got a triangle and a rectangle, and then you can work out the area of each of those separately. Remember, for triangle, it's half times base times height. For rectangle, it's just height times base. And then once you add those two together, that should give you the distance in meters. Now, again, so imagine they say work out the distance traveled between, let's say, 0 to 6 seconds. So what will you do? You're gonna first of all make a line here, turn this into what I will do is turn it into a triangle over here, and then so you've got 3 parts to work out. One is this triangle here, then you've got this rectangle over here, and you've also got this rectangle over here. So what you'll do is use your scale and then work it out. Now, what if it's a curve? In this scenario, it's going to be a little bit more challenging. So what you should do is work out the area for one of the boxes. So to do that, for example, in this one, you can see that it's going. There's 5 boxes, and over here it's 5, which means that this must be 1. And over here you got 1, 2, 3, 4, 5. 20 divided by 5 gives you 4. So we know that this is 4. So one box is going to be 4 times 1. So one box is equal to 4 in this case 4 meters. Now let's say they ask you to work out how much distance the object has traveled in, let's say, 8 seconds. So what should you do? The best way to do that is estimate how many boxes you have over here. So I'll say that'll be 1 box. This is 2. These 2 will be another box. 3, 4, 4.5, or 5, 6. So basically, you're just estimating number of boxes. So let's say eventually you found that all of this is about I don't know, let's say 50 boxes. So you're going to do 50 times by the area of 1 box, which is 4. So 50 times 4, and that should give you 200 meters. Okay, so for curves, find out 1 box, estimate the area under the curve, and just times it by the value of 1 box.
Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.